Alright, boys and girls, welcome back to the remix. We're getting a new start on 7.9. I didn't like how that got started. Okay? This is good stuff. We're going to talk about how to pull important information out of different types of equations. Okay? This equation is in factored form. Factored form makes it very easy for us to find our x-intercepts. Because what number could I put in for x that will give me 0 for y? Well, if I put in a 1, you get 1 minus 1. What's 1 minus 1? And what's 0 times anything? So one of our x-intercepts is 1, 0. What else could I put in for x that will give me 0 in a parentheses? 4 plus 3 is not 0. Negative 3. Okay, good. If I put in a negative 3, what's negative 3 plus 3? And a 0 times anything? So one nice thing about vertex form is you can identify instantly what the intercepts are going to be. Well, now that you've found the intercepts, you should imagine that the axis of symmetry is going to be right in between the intercepts, right? Because these parabolas are symmetric. So now we know the axis of symmetry is x equals negative 1. So if I wanted to find my vertex, Carson, what would I put in for my x? I would put in a negative 1, because the vertex has to lie on the axis of symmetry. And let's find out what we got. So negative 1 minus 1 times negative 1 plus 3. Well, that's negative 2 times positive 2. So I get my vertex is negative 4. Okay, the y-intercept, what do I put in? I put a 0 in for what? Put a 0 in for x. You get a negative 1 times a positive 3. That's a negative 3. Okay, this makes sense. So due to the symmetry of it, I bet this point is also right there. And now I can sketch my graph. Okay? Got it? Now, I will try to do these using your graphing calculator and not using your graphing calculator. So let's say I wanted to do the same thing in my graphing calculator. Well, oops. I could just type it in. So y equals x minus 1 times x plus 3. Close it. Okay. Graph it. Let's see if the graphs look the same. Well, that pumps me up. Okay. Let's look at our table. Oh, well, I can use my table to find both of my intercepts. Right? I can also find my y-intercept. So the only thing I wasn't able to find with the table is the vertex. Although if you look for symmetry, you can usually see the vertex. Do you see the 0 has a 0 partner? And the negative 3 has a negative 3 partner? But the negative 4 doesn't? That means that's the symmetric point. But if I couldn't do that, I could go back to my graph. Do you remember how to find second? Calculate. Good. I want to find the minimum in this version because that's what the vertex is. I got to put the water bug to the left of the vertex, hit enter, get it to the right of the vertex.
Does it matter if you do left or right first?
Yes, it does. You got to do left first. Hit enter. And notice it's approximating it to be negative 1, negative 4. From there, you can get your line of symmetry as x equals negative 1. So you could do all of this in your graphing calculator if you're good with your graphing calculator. Right, Morgan? I agree. Next. All right, so this is also in factored form. Let's just use the graphing calculator for this one. Okay? So, y equals, clear, 2 times parentheses, x minus 2 times parentheses, x minus 6. Okay, now, before you even look at it, what are the x-intercepts going to be? Positive 2 and positive 6. If I put in those numbers, it's giving me a 0. Okay, but let's take a look. Let's start by graphing it, get an idea what it's going to look like. Okay, no surprise, it's a steeper parabola. Let's calculate the vertex. Second trace, this is a minimum. Where's my water bug at? There it is. Okay, hit enter. Get it to the right of it. Come on, move, you water bug. Okay, hit enter. Take a guess in between those two spots. 4, negative 8. Does that answer make sense to you? Whoops. So, our x-intercepts are 4, 0, and negative 8, No, my bad. That's not what we found at all. Our vertex is 4, negative 8, right? So then what's our line of symmetry? X equals 4. Okay, so we could just sketch that on here. 4, negative 8. 1, 2, 3, 4, 5, 6, 7. It's all the way down there. Okay, let's go back to the graphing calculator. Let's go to the table. What are the x-intercepts? 2, 0. See it, 2, 0 right there? Okay, so your table just needs to be adjusted. If you have any problems with your table, bring it to me and I'll show you how to do that. No problem at all. So 2, 0, and 6, 0. 2, 0, and 6, 0. Uh-oh. That's 1, you idiot. Well, good, because it didn't look right. Oh, no. 2, oh gosh darn it, this is so frustrating. 2, 0, and 6, 0. There we go. Okay. Well, let's just go back to the graphing calculator to get two other points. You get 3, negative 6, and 5, negative 6. So 3, negative 6, 5, negative 6. It's a parabola. The x-intercepts are 2, 0, and 6, 0. To find the y-intercept, go back to our graphing calculator. Where is it at? At y equals, or at x equals 0. Y equals 24. So we couldn't have gotten that from our graph because it's too big. 0, 24. Okay, I'll do this one without using the graphing calculator, but let me show you how to fix your table settings. Okay, now keep in mind for this one it says g of, I'm going to change my color here. G of x. Well, it says negative x times x plus 4. Do you realize that that's the same thing as negative x plus 0 times x plus 4? It's the same thing, okay? So, let's see. You could distribute it. You could also say this is g of x equals negative x squared minus 4x. Okay, that helps, because this is a plus 0, right? So our y-intercept is going to be 0, 0. And I think if we put in a negative 4, it's going to give us 0. If you don't like this, what should you do? Use your graphing calculator. Okay, I'm just showing you two different ways. So your x-intercepts are at 0, 0 and negative 4, 0. Okay? Your line of symmetry, well, we don't know that yet, but your vertex, what's right in between 0 and negative 4, Carson? So your line of symmetry is right there at x equals negative 2. Okay? Sorry, thank you. That's what you were saying. So then our vertex is then what? Well, it's negative 2 comma something. So just plug it in. Negative 2 times negative 2 plus 4, right? That's negative 2 times a positive 2.
8.
No, negative 2 times positive 2 is 4.
Okay.
So our vertex is negative 2 comma 4. Okay? Let's put in a 1 to see what we get for that. And we know our y-intercept is also 0 comma 0. So really, we could graph it right now. I just want to be as accurate as I can. So when I put in a 1, I get a negative 1 times 5, so that's a negative 5. And then I know from symmetry that that's also going to be a negative 5. If you don't believe me, you can test it. And I'm not very accurate because of the ViewSonic, but you get the idea, right?
Yeah.
All right, one more, and then we have some other good questions. Based on these examples, how can you use a quadratic to find the line of symmetry? Well, this is x equals h if the vertex is h comma k. If you're wondering why did you use h and k, that's just what the people that came before me have chosen, so I'm trying to stay consistent. Okay? So if you know the vertex, x equals this number is the axis of symmetry. How do you find the vertex? Well, either graphing calculator or find the average x value of the x-intercepts. You know, remember how I was doing that, Carson?
Yeah, by adding on.
Yeah, find the midpoint between the two intercepts, which is the average, exactly. How do you find the x-intercepts? What numbers do I plug in to give 0 in the parentheses? Right? That's how I did that. How do you find the y-intercept? Plug in what?
Plug in 0 for x.
Plug in 0 for x. Sorry, I'm rushing. The vertical stretch, look for the number outside of the parentheses. Okay? Got it? All right. Okay, choose any two linear functions and write them in the form f of x is m times x minus c, where m is the slope of the line. So let's go y equals 2 times x minus 1, and y equals 4 times x minus 2. Okay, choose any. Now graph the functions. Well, luckily for a point, for a line, how many points do I need? Yeah, but how many do I need to graph it?
5.
Well, for a line, I just need 2,
Yeah.
because it's a straight line. So if I put in a 1, let's make this the red line. Okay? Put in a 1, I get a 0. Right? Put in a 5. 5 minus 1 is 4. 2 times 4 is 8. Okay? Let's see the best I can do here. There we go. So there's the red line. Alright, now let's make this the blue line. Put in a 2. What do I get?
You get
I get a 0. Come on, ViewSonic. Come on, ViewSonic. Put in a 2, I get a 0. I think a 5 is going to be off, so let me just put in like a negative 2. Negative 2 minus 2 is negative 4. Nope, that's too big. Let's put in a 0. 0, you get a negative 8. 2, 3, 4, 5, 6. Okay. Nope. Shoot. Blue. Alright, so look. Here's what they're just, I think, trying to tell you has happened. This number on the outside controls how steep the line is, and this number on the inside has been shifted right. How far? 1, and this one? Right 2. On the same graph as number 5, graph the function p of x that is the product of the two linear functions. Oh, wow. So they want p of x is 2 times x minus 1 times 4 times x minus 2, right? Well, we can multiply things in any order we want, right? So let's just do 8 times x minus 1 times x minus 2. So it's 8 times x squared minus 2x minus 1x plus 2. Sorry. So it's 8 times x squared minus 3x plus 2. So it's 16x squared minus 24x plus 16. So let's graph that in our graphing calculator. 16, negative 24, 16. So y equals 16x squared minus 24x, right? Yep. Minus 24x plus 16. This is going to be a funky graph. It's probably going to be off. Okay, and it's almost off the charts. So that's kind of weird that they ask us to do this. But let me look at the table. 1, 8, we'll be able to put this on there. 1, 8, and then the second one was comma 16, right? It was 0, 16. So it looks like this. The parabola. Okay? What shape is created? A parabola. Yeah. Describe the relationship between the x-intercepts of the linear functions and the x-intercepts of p of x. Why does this relationship exist? The x-intercepts. Hold on. Shouldn't this been a? Should this? I must have made a mistake. Because, yeah, I'll pause the video. Okay, if you were following along closely, you have found my mistake. 8 times x. There's my mistake, okay? So, that's going to change everything. That should be an 8x. Now let's go back to our graphing calculator and change this to an 8. And watch what that does to our graph. It shifts it down big time. Okay? Now when we go to our table, we got our, these are still our x-intercepts. Okay? And then when you look at the graphing calculator, let's see, the vertex is going to be 1.5 comma something. And I will use my graph to find that. It looks like it's down 2. So that's actually what our graph was supposed to look like. I made a mistake to get that one. So now you can see what happens if you change the a value. But now I can answer the question. It's a parabola, okay? Describe the relationship between the x-intercepts. Unchanged. Describe the relationship between the y-intercepts. Unchanged, right? And I'm just going to leave it at that because this video is already too long. We're going to keep going. Look at the parabola to the right. Sketch the two lines that could represent its linear factors. So it could be y equals 1 times x minus 3 and y equals 1 times x plus 1. Okay? So something like it could be that and that. How did you use the x and y intercepts? Well, I just used the x-intercepts here. This minus 3. Okay? And that's basically they're trying to get you to understand that these, most importantly, will give you these. Does that make sense? Okay. That'll be enough to get you to the homework. It's a good little introductory video. It really is. Thanks for sticking around. Too long. Boom!